Hey, I wanted to start your 8.3 mini lesson by talking quickly first about the activities that you did yesterday and my hope of what you should have gotten out of it. In the activity that had you estimating the area of the circle, the area of one of these squares was 1. My hope was that you found that the area of one of these triangles is half of that. And then kind of thinking about this guy, like if you were to take this piece and sort of duplicate it here, it looks like it just makes one whole square. And so there's the area of 1 as well. And so if you were to have taken the area of this whole square and subtracted out as many of those small pieces as you had seen and the area of each, this looks crazy, but my hope was that when you estimated the area of a circle, you got 78. Then taking that back to using that to help us develop the area of a circle formula, doing the area of your circle, which we said was 78, divided by the 5 squared, which we said was 25. Well, I was hoping you guys would get 3.12, and that's what would go here. So the area of a circle is 3.12 times 5 squared. So this is close to a number that you guys have been seeing a lot lately. I don't know if anybody made that connection. Now we have to go think about why on earth 5 squared. What dimension of the circle does the 5 represent? Well, this was a 10 by 10 square, which means that it was 10 all the way across, but we're not talking about 10, we're talking about 5. So what part of the circle is that? That's the radius. So the 5 represents the radius of the circle, which means that this formula up here, 3.12 times the radius squared. Interesting. Anybody notice what this looks like yet? All right, well, let's talk about this guy. Remember, you drew a circle, you called this the radius, and when you cut it apart and put it back together into a parallelogram, the height of a parallelogram is the same dimension as the radius of the circle. I also asked you about the base of the parallelogram, which if you were to take these apart and you put half of them, maybe I shouldn't do that in green, you put half of these guys, 12 of these wedges on one side. So all of this, that's 12 of those wedges, 12 of those wedges, which means that the base of that parallelogram is half of your circumference. This here, that's half of your circumference. Well, would you look at that? And if we know that how you find the area of a parallelogram is base times height, well, the base is going to be half of our circumference. Well, how do we find circumference again? Pi times diameter. And then the height of our parallelogram is the same as the radius of our circle. So this is how you would find the area of that parallelogram if you're thinking about the parallelogram in terms of parts of a circle. So, well, this looks a little crazy, but half of pi times diameter, half of the diameter is the radius. So it's radius times pi times radius. Now if you multiply radius by itself twice, you can call that radius squared. But we're still multiplying by pi, so it's pi times radius, which is pi times radius squared. That, boys and girls, is how you calculate the area of a circle. Bringing us over to now our lesson for the day. Look, area of a circle. is pi, which you know to be 3.14, times the radius squared. Voila. Let's apply it. Sometimes pi is going to be approximated with a fraction. If you were to do 22 divided by 7 on your calculator, you'll see that it's really close to 3.14. So 22 divided by 7, 3.14. See that? So sometimes they'll say use 22 over 7 instead of 3.14. And the reason they do that is because sometimes you're going to be given a dimension that is a multiple of 7, which makes it a little bit easier to work with, depending on your feeling about fractions. So if we're going to find the area of a circle, we always do. Area is pi times the radius squared. Well, as it turns out, we are given the radius is 7. And so here where we see radius, we're going to put a 7. We're going to do 7 squared. And where we see pi, we're going to use 22 over 7. So we're going to go 22 over 7 times 7 squared. So we're going to do exponents first. So we're going to go 7 squared, well, that's 49, times, and we still have the pi as 22 over 7. And this is why they wanted just to use 22 over 7, because if I were to multiply these fractions now, 49 over 1, I can do 7 into 49, so 7 divided by 7 is 1, 49 divided by 7 is 7, and now I can multiply straight across and just do 22 times 7, and that'll be my answer. 22 times 7, 154. 154. We're going to do centimeters, and now because we're talking about area, we're going to do square units, which just means little squares inside here. 154 little squares that are of size centimeter by centimeter would give us the area of that circle. Okay? So, again, if we're finding the area of a circle, we're going to start with area is pi times the radius squared. That's our formula. In this case, they want us to use 3.14 for pi. So where I see pi, I'm going to put 3.14. And I'm going to have to multiply by radius squared. Now look over here. Whoopsies, I didn't mean to cross that out. We have not the radius given to us, but the diameter. The diameter is 26. So if I know that the diameter is 26, I'm going to divide it by 2 because radius is half of the diameter. So in this case, I know that the radius, let me do this in a different color. If I divided it half, then I know that the radius is going to be that answer. The radius is 13. So this takes a little extra step because now I'm going to go radius is 13, and remember it's always radius squared. So I'm doing 3.14 times 13 squared equals, now I'm going to give you the gift of a calculator. So I'm going to go 13 squared first. 13 squared is 169, and I still have the 3.14. I'm going to multiply by, I got the answer to 13 squared, which was 169. And now my last step, times pi, 3.14, 530.66. 130.66 inches squared. Remember, that's going to be 130 little squares that fill up this space. And that's why we do inches squared. It just means little squares. All right, so far so good. Describing a distance, you want to find the distance of monster truck travels when the tires make a 360-degree rotation. So with 360 degrees, it's just one rotation all the way around. And if it's rolling, you know, here's your tire and it's rolling, it goes this way. Gosh, what a terrible picture. My point is, it's the distance around the outside of the tire that tells you how far you're going to go. And the distance around the outside of the tire is your circumference. Okay, last one. we're going to find the area of the semicircular orchestra pit. So we're going to find this area here. Yeah? And again, remember area, so I would always start by going area is pi times the radius squared. We can do pi however we want this time. I'm going to go ahead and do pi is 3.14. Okay? Now I'm going to go times the radius squared. Well, over here in my picture, I'm not given the radius, I'm given right now the distance all the way across, which is the diameter. Now if I want the radius, remember, I'm going to cut it in half, and the radius, in this case, is 15. So the radius of this guy is 15. So I'm going to now say times 15 squared. Well, great. I'm going to do my 15 squared first. 15 squared, remember 15 times 15, so 225. So this becomes 225 times pi, 3.14. All right, and so we have 225 times 3.14 equals 706.5. 706.5. I believe we're looking at feet. Feet squared. Oh wait, you say. Good, I'm glad you caught me. Because that would give you the area of the whole circle, yes? But we are looking at half of it. So now take all of it, cut it in half, divide by 2, 353.25. 353.25. That would just give us this half that we were looking for. Remember, it's square feet. And you're done. Sorry about the lengthy video, but I do hope you found this helpful. Good luck on your assignment today. Let me know if you have any questions.